Hello students. So I am here with the solutions for the model paper 1 related to the Karnataka CET, and the PDF form of the question paper is there in the description box. You can download that. Okay, and here is the solutions. So now let us discuss the right answers and the reasons. Fine. The first one. What is the entropy change when 1 mole of ice is converted into water at 0 degree Celsius? So you are given with enthalpy of change or change in enthalpy for this particular process. Now, which formula to be applied? So this is a question from thermodynamics, as you know. So let me begin the first one. How to solve this? You have entropy formula. Change in entropy delta S is equal to delta H divided by T. And we are given with delta H, it is 6 kilojoule. So answer entropy is in joule per Kelvin. So convert this into kilo into joule. So you have 6 into 10 to the power 3 divided by temperature given is 0 degree. So which is nothing but 273. And it is 6000 divided by 273. So your option is. Am I right? 21.98 approximately you calculate, you will get that. So it is joule per Kelvin per mole. Am I right? So which option to be selected? Option D is the right choice for this. Is that okay? Yes. Second question. Number of atoms in 558.6 gram of iron. So how many atoms are there in the given mass of a substance? And this is directly from the mole concept, stoichiometry. What you know is 1 mole of any substance occupy or contains Avogadro number or occupy 22.7 liters at STP, or it is having Avogadro number of atoms or molecules or particles generally. So now in 558 gram for 550.6 gram, how many such atoms are there is a question. So what you do here, you connect that mole concept. You find out how many moles of iron present in 558.6 gram. You calculate it. Then individual options you go for. Okay, searching which will be equal then. So what do you do? 558.6 gram of iron is equivalent to 558.6 divided by, so one iron atom atomic mass is given 55.86, so exactly 10 moles. Am I right? You search in options whether it is twice that of 60 gram of carbon or the 6.022 into 10 raised to 22 or half that of 8 gram of helium, etc., etc. you have to see. So obviously option D is invalid because 5, you cannot multiply Avogadro number with the atomic mass or molecular mass given directly. So option D is ruled out. Then 10 mole of iron is nothing but 10 into Avogadro number. So 6.002 into 10 to the power 24 it has to be. But the option 22 is given power 10 to the power. So that is also ruled out. So B and D is not valid. Now let us see A, option A, twice that of 60 gram of carbon. We have 60 gram of carbon is equivalent to 60 divided by its atomic mass 12. So that is 5 moles. Am I right? 5 moles. So exactly double. Am I right? So how many atoms are present in 60 gram of carbon? Double that you have in 558.6 gram of iron. Therefore option A. As such, if you observe half that of 8 gram of helium, 8 gram of helium is nothing but 8 by 4 because atomic mass of helium is 4. So 2 moles. So it's not half of that anyway, right? So therefore option A has to be selected. Next, moving on to the third one. Inductive effect involves. So what is inductive effect? What is mesomeric effect? What is resonance or mesomeric effect? One and same, or they are very close to each other. Then you have got their hyperconjugation effect. Am I right? All these things you studied. So inductive effect, hyperconjugation effect, mesomeric effect, and one more is electromeric effect. These 4 effects. Now inductive effect involves transfer of or delocalization or complete transfer, it is, of sigma electrons. In the option if you observe, it is displacement, right, delocalization, etc., etc. given. So pi electrons anyway it is not possible. So displacement or delocalization not possible. Now the option is B and D. So delocalization, is it delocalization? What do you mean by delocalization? It will come back again, right? But inductive effect is a permanent effect. So as a result, it is displacement, permanent displacement of sigma electrons. It is not displacement of sigma electron. So option B, it is a factual or direct question. So B has to be selected. Okay, because it is displacement of sigma electrons. Next, hope you know what is inductive effect, right? Like this. So CH2 double bond CH Cl if you have, right? This chlorine can here transfer its electron, lone pair of electron like this. So then it will become resonance effect. So it's example for both resonance as well as inductive. Am I right? Or it can pull the electron from here. So this is one example where both the effects are present. Or directly if you observe this effect. Am I right? So how one can show that effect? Here it is. Okay, you can think about a carbon chain like this, CH3, CH2, CH2, and put a halogen. So it drags electron, that is sigma electron, towards itself. So this gets partial negative charge, and here comes the positive, and here that will be delta plus or delta plus you can write. Am I right? So magnitude decreases with the increase in distance, that also you have seen. So option B. Next, coming to the fourth one. Kp for H2 plus I2 giving 2Hi will change with, Kp stands for equilibrium constant, and you know equilibrium constant is a constant at a constant temperature. So it is not going to change with by changing pressure or the other parameters like number of moles or molar concentration, etc. It will change only by changing temperature. So temperature is very important there. As a result, as long as temperature is constant, equilibrium constant, whether it's Kp or Kc, is going to be constant. So your option for this is D, because it depends on temperature. Next, fifth one. The alcohol obtained by the hydrolysis of oils and fats is, so these oils and fats are nothing but esters of glycerol, isn't it? So it is ester formed by the reaction between fatty acids and glycerol. So alcohol used is glycerol there. So esters of glycerol it is with fatty acids. So option A, glyceraldehyde, what we call glycerate, isn't it? So option A here. So if you want, then stearic acid ester you can write with the glycerol like this, CH2OH, CHOH. Am I right? So this is how you used to write glycerol, CH2OH. Now ester formation with stearic acid, that is C17, so formation reaction, H35COOH. It is stearic acid. Now ester, how it is formed? From carboxylic acid you are going to have OH group and here H. So this ester is formed. So 3 molecules. Am I right? So if I write that ester formation, how the ester is going to get formed, here itself I will include that ester group. So you have O, here it is C double bond O, C17H35. Here also C double bond O, C17H35. Is that right? Are you getting? Double bond O it is. Okay, or let me put that here down. C double bond O. Now it's clear. And C double bond O, C17H35. So ester of fatty acid with the glycerol. So that is option A. Next, sixth one. The test used to identify peptide linkage in protein. Molish test is for carbohydrates. Also it is answer. It is going to answer for proteins containing carbohydrates. Then an anhydrine test is for protein again. Biuretic test is especially, of course, for proteins, but it is used to determine or identify the peptide linkage present in it. So that is the best answer out of this. So option C has to be selected. Is the right choice for this question. Okay, moving ahead. The next one. That is seventh one. The amino acid which is not optically active is. So if you observe the list in the biomolecule chapter, it is given different amino acids. A tabular column is given. If you observe there, okay, you will get to know which is the not optically active. By the way, what is optical activity? It's chirality, isn't it? Chiral carbon atom is very important. So if you observe that glycine, first member of amino acid, what is the formula? CH2COOH, and here comes NH2 group. Now this is a glycine for you. Now if you observe, is there any chiral carbon atom? Chiral in the sense carbon atom attached to 4 different groups. Here you have a carbon atom, this one, but it is attached to same 2 atom, isn't it, hydrogen, therefore it is not optically active. So option C must be selected again. Next, 8th one. Which of the following is the strongest base in aqueous solution? So trimethylamine, aniline, dimethylamine and methylamine. So basicity of amines you have studied in aqueous phase. In aqueous phase, absolutely the secondary amines or secondary amines are going to be the strongest bases because of 2 important effects. That is hydration effect and hydration or solvation effect or hydrogen bonding effect we call, and the other effect is inductive effect. So both these 2 effects are favorable for secondary amine. Am I right? If alkyl group is methyl, higher alkyl group, then the third effect comes into picture, that is steric effect, so which will destabilize the hydrogen bonding. As a result, the primary and tertiary, among them there is an interchange, right, the order. But here it is methyl is asked, so dimethylamine being secondary amine, you have strongest or highest basicity for that. So option C, because secondary amine you can write reason. Okay, it is a secondary amine. Is that fine? So shall we move on to the next 9th one? Okay, 9th one. C6H5NO2, which is nothing but nitrobenzene, stannous or tin plus HCl, so stannous chloride, and in the basic medium you will get C6H5X. So what is X in the given reaction? It is a laboratory method to prepare aniline. So X is supposed to be NH2 group. Option C, lab method, right, for aniline. So this will conclude it. Next, 10th one. So this is 9th one. Hope you can see. Yes. C6H5N2 diazonium chloride is given and is SnCl2. So SnCl2 is a stannous chloride, is a reducing agent. So reduction of diazonium chloride in the presence of stannous chloride will give option B as answer. So what is that? Phenyl hydrazine hydrochloride, isn't it? Phenyl hydrazine, because NH2 NH2 is a hydrazine and HCl is there, so hydrochloride, and upon that H is of that of hydrogen is replaced by C6H5. So phenyl hydrazine hydrochloride is formed. Next, the 11th one. In which of the following cases, does carbon atom has 0 oxidation state? Find out the oxidation state. It is option C, because CH2 might have been solved this, Cl2. So carbon X you take, hydrogen plus 1 into 2, 2, and chlorine minus 1 into 2 minus 2, that is equal to 0. So option obviously C. 12th one. In Fe 0.950, that is, what is this type of oxides called? We come across in redox reaction as well as interstitial or non-stoichiometric compounds, isn't it? So iron atom has oxidation number. What is the oxidation state of iron? How to find it out? Your usual method, FeO, in that iron composition 0.95. So what you can do is 0.95x plus 1 into oxygen minus 2 equal to 0. So x equal to 2 divided by 0.95, right, which is nothing but 200 by 95, which is nothing but 19, and here it is 40. Am I right? 40 by 19 and with the sign plus. So option B is a right choice. Next, 13th one. Which one of the following sets of ions represent a collection of isoelectronic? What are isoelectronic species? Those species having same number of electrons. So if you observe as such, see option B, barium and strontium, which cannot be because they come down the group, right, in alkaline earth metals. So strontium atomic number 38, whereas barium it is 56. As a result, they cannot have same number of electrons. And N3 minus and O2 minus, obviously no. Then here, or at least sulfur is there in that set, isn't it? So it cannot be. Lithium, sodium, magnesium, they anyway cannot be. So option A, which is isoelectron species of 18 electron. Okay, so option A, all have 18 electrons. Yes. Next, 14th one. The de Broglie wavelength of tennis ball of mass 60 gram moving with a velocity of 10 meters per second is approximately. So de Broglie wavelength is asked. We have a formula for that. Lambda equal to h divided by m into v. Hope you can substitute now. Lambda equal to h divided by m into v. So you can substitute for h, which is a constant. So I'll do that 6.626. Am I right? Into 10 to the power of minus 34 divided by what is mass? It's told at 60 gram, but remember lambda wavelength, so it should be in kg in de Broglie equation. So 60 into 10 to the power minus 3 put, and it is in meter anyway, so 10 meters. Am I right? So this you write as 60 into 10 raised to minus 2, and here 10 again, so 10 to the power minus 1. When it comes to numerator it is 10 to the power minus 34. Am I right? This will become plus 1. So 6 by 6 you cancel it 1.1 times, isn't it? So this is 1.1 into 10 to the power minus 33 meter. Is that right? Yes. So which is the answer? Option A. It is of the order of 10 raised to minus 33. So your option is option A. Yes. 15th one. Which of the following is the expected magnetic moment of Fe3 plus? So iron that is in ferric state, what is the magnetic moment is a question, and we have a formula for magnetic moment. Mu is equal to root of n into n plus 2 Bohr magnetone, isn't it? So what is the n value? Number of unpaired electrons. In Fe3 plus, how many unpaired electrons are there? So how to calculate it? Let me do that here. Fe3 plus electronic configuration, argon gas structure 18. Next it is 4s2 and 3d6. 4s2 and 3d6. So 2 electrons from the 4s subshell and or 4s orbital, and 3d electrons out of 6, 1 will be removed. Totally 3 plus state. No, so it is 3d5. How many unpaired electrons are there? There are 5 unpaired electrons. So n equal to 5. 5 into 5 plus 2. I'm just telling you the method also. So root 35. Bohr magnetone. So option is there? Yes, option C is the right choice for you. Is that okay? Hope you are following. Yes. So moving ahead, 16th one. Let me erase this. Okay. Sixteenth question is related to covalent compounds have low melting point because. So it's a conceptual question. What is the reason? Covalent molecules are held by, see, melting point or boiling point is depending on what? The intermolecular attractive forces, isn't it? So low melting point or boiling point clearly indicate that intermolecular forces are weak or weaker at least, right? So therefore you can select, or rather you have to select option B, which is again factual question directly. 16th one is B. Okay. Next, 17th. The maximum number of hydrogen bonds that a molecule of water can have. Any idea? So water molecule structure is like this: O, H and H. Right. So oxygen valency, now 2 more, so it can form 2 hydrogen bond with the other water molecule like this, isn't it? So H, O, H. Next, the 2 hydrogen atoms present, no, they can also be involved in hydrogen bonding like this with the oxygen atom of other molecule. So you can find out now how many hydrogen bonds possible per water molecule. So I am focusing on this water molecule, right? So totally 1, 2, 3, 4. So option B is the right choice there. Next, 18th one. The main axis of diatomic molecule is Z. So internuclear axis is Z. The orbitals px and py overlap to form pi molecular orbital or sigma or delta, or no bond is formed. So which one do you think? Internuclear axis is Z and one orbital is y axis and the other one is in x axis. Is there any bond formation or overlapping? Definitely not. Why? Because in MOT theory, molecular orbital theory, you studied something called as linear combination of atomic orbital, LCA rule. which says that the combining atomic orbital should have same symmetry. The symmetry of the combining atomic orbital should be same. That is, s orbital can overlap with another s orbital, px orbital can overlap with another px. There is no overlapping possible between px and py, because extent of overlapping is very, very less. So thereby the option is D, no bond is formed. Option D, because you can write LCA rule. Okay, next, what is LCA stand for? It stands for linear combination of atomic orbital. Okay, 19th one, the number of alpha particles emitted by, so it's a nuclear decay process, isn't it? So decay of polonium, which is chalcogen, is taking place there. Am I right? So it is nuclear decay. So I can write that equation here now to make it clear. So polonium 218 and 84, yes, disintegration of polonium nucleus, and it is lead which is going to be formed 206 and 82. Now how many alpha particles? Alpha particle is nothing but a helium nucleus. So let me write that, plus helium, He24. Now to balance the mass, see, because the other is beta particle, and you know beta particle has got 0 and -1 charge, electron it is. Am I right? Now to balance this atomic number, you have alpha particle 2. So it's balanced, left hand side and right hand side. But mass is not balanced, you see. So 218 and 216, so 12 units. Now only 4 we have. So what else? You have to multiply this, isn't it? So multiply this by 3. So 3 into 4, 12. 12 plus 2, not 6 is 218. So it's balanced. Atomic number 84, 82 plus 2, right? And 6 here. So 84, 82 plus 6 is 88, and minus how much? In order to make it 84, 4. So 3 beta particles and 4 alpha particle. Sorry, 3 alpha particle and 4 beta particle. So your right choice supposed to be option A. 20th one, excess of sodium ions in human system causes, so obviously high blood pressure, BP, it will be high. So option D. Next, 21st one, the spin-only magnetic moment of nickel 2 plus in aqueous solution would be. So what is the spin-only magnetic moment of this? How to calculate it? Again, the formula is here. It's a bit different type of problem, that's it. So what you do is nickel oxidation state is 2 plus, so organ gas structure 18, then 3D system is 3D8 and 4s2. 4s is 0 now, 2 electrons are lost. So 3D8 in the sense how many unpaired electrons are present? So 5d orbital like this. So 1, 2, 3, 4, 5, 6, 7, 8. So unpaired electrons, right? N equal to 2. So substitute N equal to 2 in the same formula, right? So you will get it as option A. It is 2.84, right? Square root of 2 into 2 plus 2. So square root of 8 is very close to 9. So 3, 2.84. Next, 22nd one. The number of unpaired d electrons in Fe2 plus ion. How many unpaired d electrons are there in Fe2 plus ion? So Fe2 plus indicate organ gas structure 18. Next, 3d6, 4s0, because atomic number is given 26. Now d6 configuration you write. D6 is here 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 and 6. How many unpaired electrons are there? N equal to 4. So option A is the right choice for this. Yes. So we have completed 22 questions. Let us move on to the next set. Okay. Yes. So hope this much is clear to you, whatever we discussed now. Yes. So let us move on to the 23rd one. Here it is. Which of the following biomolecules contain non-transition metal ion? Vitamin B12, cobalt, right? Cobalamine we call, so it is CO3 plus state in that. Then chlorophyll, magnesium 2 plus ion, hemoglobin, iron 2 plus, and insulin. Interestingly, insulin contains zinc. Okay, so non-transition as such, if you observe, chlorophyll, magnesium, and zinc also, it is a D block element, but as such it is not a transition element. But better choice if you see, S block element magnesium is, right? So which is not a transition element. So D block element we call it as transition element, most of them, though zinc is not pure transition element. Right choice or the best answer here is option B. Okay, option B, because Mg2 plus is S block element. Okay, done. Next, 24th one. The oxidation state of chromium in chromium complex with ammonia and chloride, right? Chloride radical or chlorido or ligand. So we'll write it CrNH3 4 times Cl2 plus. So write it as X. We don't know the oxidation state. Ammonia, it is 4 times into charge is 0 plus 2 chloride ions minus 1. Net charge is plus 1. So X equal to plus 3. Option is D. Next, 25th one. A ligand can also be regarded as, so it's one of the theory anyway, crystal field theory also is studied, because interaction, according to that, the coordinate bond formation or the coordinate complex is visualized as electrostatic attraction between the negatively charged or point negative charge we call ligand as. Fine, that is one of the concepts. Then whatever the theory you learn in that or learnt in that chapter, which clearly says that ligands are those which donate pair of electron, whereas metal atoms or the empty orbitals of the metal will act as electron acceptor. So that is Lewis acid. Metals are Lewis acids because they accept a pair of electron. Ligands are Lewis bases. So option A. Remember that. Next time it could be metals. There it is, Lewis acids. Next, 26th one. How many EDTA molecules are required to make an octahedral complex with calcium? Octahedral coordination number is 6 and your EDTA is a hexadentate ligand. So one molecule is sufficient to bond, right, with calcium in the octahedral way. So option C, because EDTA is hexadentate ligand. Am I right? Hexadentate ligand. Next, 27th one. In thermite process, the metal used as reducing agent is, so it is aluminothermite process, the metal used as a reducing agent is aluminium. So option C. As such, this is from metallurgy, but anyway you have a oxidation reduction chapter, no? From that also you can tell that this is from that chapter, or from that chapter also this question can be asked. So remember, reducing agents is given, so we can visualize this as a redox chapter question. So aluminium is the right answer. Next, 28th one. Among the following statement on the nitration of aromatic compounds, the false one is, so incorrect statement is asked. The rate of nitration of benzene is almost same as that of the hexadeuterobenzen. That is a correct statement. The rate of nitration of toluene is greater than that of benzene. So let us see which is a false statement or which is a right statement. Both of this cannot be the right, either A or B supposed to be the answer, because these two deals with rate. It cannot be same or greater at the same time, right? So it should differ. So option or choice is between A and B for us now. The rate of nitration of benzene is almost same. So they are telling that benzene formula C6H6 and hexadeuterobenzene is C6D6. So rate cannot be same because both the atoms, hydrogen and deuterium, different in terms of mass, right? One which is heavier is less reactive, as we know, right? Our mass also, if increases our movement, which is related to rate, gets slower, isn't it? Or it becomes less. So as a result, C6D6 rate has to be less compared to C6H6. It is not greater. So right answer is rate of nitration of toluene is greater than benzene. That is true. So rate of nitration of benzene is almost same. That is not true. The right statement has to be C6D6 rate is less compared to that of C6H6. Is that fine? So option A is the incorrect statement, therefore that is the right answer here. Next, 29th one. As temperature is raised from 20 degrees Celsius to 40 degrees Celsius, average kinetic energy. So kinetic energy from states of matter, or in that chapter you studied that kinetic energy is directly proportional to the temperature. So therefore we can write kinetic energy at the second temperature or higher temperature to that of lower temperature is equal to T2 by T1. So this is nothing but 40 degree in the sense 273 you have to add, so 313 divided by 20 degree 293, right? Yes, that's all. So right option is option C in that case. Next, 30th one. If 300 ml of gas at 27 degrees Celsius is cooled to 7 degrees Celsius at constant pressure, the final volume is. So it's volume and temperature relation. So you know Charles law to be used. So V1 by T1 equal to V2 by T2. We can compute it. So V2 is equal to what? V2 is, we have 300 as a volume initial into temperature related to that is 280 anyway given. 280 how it is? 7 degree, no? Yes. Divided by higher temperature T2 is 27 degrees Celsius, which is 300 Kelvin. So cancels, 280 is the answer. So right option is yes, D. So that is about the first half of the paper for you. So let us move on to the next 30 questions quickly. Okay. Yes. So the next 30 questions like this. Yes. We have 31st one. The solubility product of binary weak electrolyte. So it's solubility product of AB type of salt. So directly I will move on to that. So KSP is equal to S square for AB type salt. AB type salt. So what is solubility equal to? Square root of KSP, isn't it? So KSP is given, that is nothing but root of 4 into 10 to the power what? Minus 10, and answer is 2 into 10 to the power minus 5 molar. So option B. 32nd one. pH of solution produced by mixing of two solution, different pH solution, pH 6 and pH 3. So what we want is total H plus concentration in order to find out the mixture's pH. So let us find out H plus in total, right? Total equal to what? pH 6 in the sense 10 to the power minus 6. pH 3 is 10 to the power minus 3 divided by average 2. So why it is so? pH equal to minus log of H plus concentration. This one supposed to know. Now pH 6 is equal to what? Minus log of H plus. So how to find out H plus? Minus 6 equal to log H plus. So H plus equal to anti-log in the sense 10 to the power minus 6. Similarly, we have 10 to the minus 3 solution concentration of H plus. So this is it. Now you can find out 10 to the 3 is common. So this is 1.001 by 2 into 10 raised to minus 3. So I'll write as a 0.5 into 10 to the power minus 3 or 0.5 into 10 to the power minus 4. So how to find out pH of it? Therefore, pH is equal to minus log of how much? 0.5. Sorry, it's 5, isn't it? I have shifted one decimal point. 5 into 10 raised to minus 4. So it is 5 into 10 to the power minus 4. So minus log 5 is 0.6990. So we'll write as a 0.7 approximately. Plus what? Minus of minus will be plus 4. So 3.33. So right option is yes, option D. Next, 33rd one. How much it is? The pH of gastric juice is normally, so it is acidic pH, option A factual question. 34th one, concentration of decimolar solution changed to centimolar solution, centi in the sense 0.001, deci 0.1. In a first order reaction in 100 seconds, the rate constant, direct question, rate constant related. So rate constant K equal to, so rate constant K is equal to 2.303 divided by T, that is 100 seconds, I am writing directly, into decimolar 10 to the minus 1, centimolar 10 to the minus 2. So this will be 10 to the plus 1. So log 10 is 1. So it is nothing but 2.303 into denominator 100 is there. So when it comes to numerator, minus 2. Right? So first order, so second inverse is the unit. So option for the 34th one, A. 35th. For a reaction A plus B giving products, the order with respect to A is 1 and with respect to B is 2. What should be the rate of or rate if concentration is doubled? So you know that rate constant is proportional to, rate is proportional to rate or equal to rate constant into concentration of the reactant. Concentration A and concentration of B. They are telling with respect to A order is 1 and with respect to B it is 2. So what happens if it is double? So R dash, let me write, equal to K into, I'll write 2A doubling, so 2 times, and 2B, so that is square. So overall it will be K into, okay, concentration of A to the power 1 and B to the power 2. I'll take that to outside. So 2 into, here 2 square is 4. So this is going to be 8 times and remaining is said to be R. 8 times the R. So your R dash is 8 times the R. Option C is the right choice. Done? Yes. Moving ahead to the next set of questions. So I have completed 35 questions. Moving on to the next 36th one. Yes. So most of them are NCERT related only, because as the syllabus is released related to the KCET. So deleted portion is not included generally. Anyway, they told, but there is absolutely, we cannot predict how it will be. Chemical reaction with very high activation energy values are generally, so this is the actually deleted portion, but anyway, activation energy is a part of your kinetics. You cannot think of the chemical reaction and rate, right, interrelation without the activation energy. That is the main reason for different rates of a reaction. So activation energy, if it is high, the rate of the reaction is going to be less, or rate is slow. Why it is so? You have to understand this graph, that is sufficient. Okay, so it is potential energy and this is a reaction coordinate. So graph will be bell-shaped curve. Now you can understand here, this is called as activation energy, EA. More the height of this graph or bell-shaped curve, then rate is slow, because it has to reach that height then come back, isn't it? So as the distance, this energy barrier increases, speed becomes less and less. So this is energy of the reactant, this is energy of the product. So once this threshold value or activated complex state is reached, then only product formation possible. So that height if increases, reaction becomes slow. So option 36th one, it is very slow, B. 37th one, the first order reaction concentration of reactant decreases from 0.8 to 0.4 in 15 minutes. So what they are telling is 0.8 if you take molar solution, it will reduce to 0.4. Isn't it half of it in 15 minutes? So half life is given. This implies T half is equal to 15 minutes. Now what is the time needed for concentration to change from 0.1 to 0.025? Let us understand that 0.1 molar we take and it will be reduced to half of it, 0.05 molar. Then it will reduce again half of it, 0.025. So what they have asked is this time, isn't it 2 times the T half? 2 times T half is 15 minutes, 2 into 50, 30 minutes. So option A is the right choice for that. Next, 38th one. Which of the following is not a characteristic of chemisorption? Chemisorption is a unilayer thickness or unimolecular adsorption it is. So here it is, the adsorbed layer is multi-molecular told, which is absolutely wrong. So your option for this question is A. 9th one. Identify the gas which is readily adsorbed by activated charcoal. So all the other gases, if you observe except B, are homogeneous gases. So obviously one which is different is heterogeneous, option B. You write there if you want the reason. Heterogeneous gases are adsorbed to a greater extent, okay, than homogeneous gases. So option B, SO2 is heterogeneous gas. So therefore it is going to adsorb to a greater extent. 40th one, solutions with same osmotic pressure are called directly isotonic solution. So option C. 41st one, which of the following organic compound exhibits both failing test as well as the iodoform test? So you know that for iodoform test will be given by those compounds. Iodoform test implies that methyl ketone group should be there. So methyl group should be there attached to the ketone group. So these compounds will exhibit. Therefore methanol, ethanol is again not valid. Propanone has got that group, CH3COCH3, fine. But failing reagent test will be answered only by aldehydes. Ketones won't answer. So among these, aldehyde is ethanol, so which is nothing but H here. So therefore ethanol will answer this test. Both option D is the right choice there. Next, 42nd one. Formaldehyde on shaking with concentrated NaOH solution undergoes. So directly formaldehyde is aldehyde without alpha hydrogen, Cannizzaro reaction. So option C, okay, HCHO formaldehyde is, so no implies that no alpha hydrogen. So definitely it will answer Cannizzaro reaction. 43rd one. Heating sodium benzoate in the presence of dilute NaOH is decarboxylation type of thing, type of reaction. So sodium benzoate, if you remove that carbon compound, isn't it, COONe, then it is benzene which is going to form. So reaction, if you want, you can write like this: COONe, sodium benzoate with NaOH dilute. So what happens here? C6H6, it will be benzene, C6H6 plus what? Na2CO2 and O here CO3. So sodium carbonate is going to be formed as a byproduct. So 43rd one is benzene, option A. Yes. So remaining 17 more. Okay, we'll move. Fine. Moving on to the remaining questions within a minute. Yes. Fine. Yes. Done. 44th one now. The best method for the conversion of an alcohol into alkyl halide is by treating the alcohol with haloalkane chapter, alkyl halide. It is thionyl chloride method, isn't it? Which is also known as Darson method. So option B. Why it is so? Because when you add R, hope you can see this reaction. No. So let me write it down. Yes, from here. 44th one. So option B is the right choice. Why? Because when ROH is treated with the SOCl2, right, in the presence of pyridine, what do you get? You get RCl plus what? SO2 plus HCl. So both these are gases, so they escape out. So no separation technique is required. Obtained RCl is pure itself, right? So therefore this is a best method. Next, 45th one. An alkyl halide react with the lithium dialkyl copper to form alkane. So option A. One of the method of preparation of alkane in hydrocarbon you supposed to come across, right, about this method, or you came across rather. So this reaction is known with the name Corey-House reaction. Have you heard about it? Corey-House reaction. What is this reaction? When alkyl halide RH is treated with a dialkyl copper lithium in the presence of ether, what happens? Exchange. So R dash I will write for this, or I will write R dash here, just to differentiate two different alkyl groups. So you will get R dash here, then plus what? Alkyl copper and lithium halide. Is that okay? So this is about the Corey-House reaction. Next, 46th one. Neutral ferric chloride gives purple color with phenol. So ferric phenate is formed. Therefore, okay, when you treat Fe3 plus ions from ferric chloride and phenol C6H5OH, the hydrogen will be replaced by electropositive metal. So you'll get C6H5O thrice Fe, purple color. That is nothing but ferric phenate. Done. Next, 47th one. Sodium phenate is when heated with carbon dioxide under 6 to 7 atmosphere pressure followed by acidification. See how they ask the coal-base reaction in a sentence wise, isn't it? So formed is orthohydroxybenzoic acid, option C, because it is coal-base reaction. Yes. Next, 48th one. The osmotic pressure of 1 molar solution at 27 degrees Celsius, from solution chapter, osmotic pressure. How to calculate it? Formula, pi is equal to C into R into T. Am I right? Where C is molar concentration, R is a gas constant, T is a temperature. So concentration 1 molar, R, since atmospheric is asked, unit of R in terms of atmosphere is 0.0821, into temperature is 27, that is 300, 3 into 8, 24, right? So the option is 24.6 atmosphere pressure. So therefore your option B is the right choice. 49th one. A compound formed by elements X and Y crystallizes in a cubic structure. So solid state, X atoms are present at corner, X at corners. So you know corner contribution. How much it is? 1 by 8. There are 8 corners in a cube. So X atoms are 1, or it is 1. Next, Y at face center, FC. So face center contribution is 1 by 2, and there are 6 faces in a cube, so 3 it is. So X, Y, 3 is the formula, option B. Next, 50th one. For an atom A, which of the following is correct with respect to the radium? So you supposed to remember 2 important statements. We call it as a golden statement in periodicity chapter, or classification of elements and periodicity. What is that? Size of anion is always larger than its parent atom. So when anions are formed, effective nuclear charge is going to be decreased, so the size expands. Similarly, size of cation is smaller than its parent atom because of increase in effective nuclear charge, so size decreases. As a result, anion is A minus, so its size is highest, then A neutral atom, then A plus. So right option is C. 51st one. The metal present in insulin is already we came across, right, in another question about it. So it is zinc, which is a metal present in insulin. 52. The EMF of a galvanic cell constituting couples, that is zinc half cell and the other half cell, which is told there, zinc and which is the other one, copper. So your Daniell cell, it is normal electrochemical cell which you come across. So Daniell cell, you know how to calculate EMF. So EMF of this cell is equal to EMF of cathode minus EMF of anode, or electrode potential of anode. So if you say it is a standard, then obviously E naught we can write, but it's given cathode is copper, therefore we have it is 0.34 volt. Is that right? 0.34 minus 0.76 volt. So overall 1.10 volt, that is plus. So option B is the right choice for this. Yes. So with this, last 8 questions, let us focus on. Fine now? Yes. Coming to the last 8 questions on this model paper. Yes. 53rd one. Okay, you are given with phenol, then chloroform, NaOH and HCl. So phenol plus chloroform, the product X is, any idea? Riemann-Tiemann reaction you might have been heard, isn't it? So the product is that salicylaldehyde. So option C, because it is Riemann, right? Tiemann reaction. Yes. Next, 54th one. Pure methane can be produced by Woods reaction. Is it possible to get methane from Woods reaction? Definitely not. Why? Because Rx plus Rx. So you will get double the R group, number of carbon atoms. Am I right? 2 R groups. So methane having only 1 carbon atom, you cannot get from half anyway, isn't it? So Woods reaction limitation is that methane cannot be prepared. So it's wrong. Colway's electrolytic reaction. There also you will get the number of carbon atoms formed will be in electrolytic method, sodium salt of carboxylic acid to be taken there, right? So RH you will get, or RR. In electrolytic method, what happens if you take CH3 COO right, on electrolysis, just I'm writing, okay, just remembering the studied reaction, then you'll get CH3 and CH3. So first compound obtained is nothing but ethane, not methane. And instead of this, if you take your the formic acid derivative, then you will get hydrogen. You are not going to get anyway the carbon containing, that is hydrocarbon. So as a result, because this will be removed, Na2CO3 as sodium carbonate, so only H is left. So methane cannot be obtained even from Colway's electrolytic method. As a result, these two methods won't give absolutely methane. Now one remaining is soda lime decarboxylate. That is possible. So CH3 COO Na, when treated with NaOH in the presence of calcium oxide, you will get CH, H will be added from here, CH4, methane plus what? Na2CO3. So this is possible or method to obtain methane. So option pure it is anyway option C. 55th one. In which of the following is reduced by zinc mercury, that is zinc amalgam and HCl to give corresponding hydrocarbon? And we studied this is Clemenson's reduction. So aldehydes and ketones will give corresponding hydrocarbons. So we have option B where it is ketone, and acetamide is amide, ethyl acetate is ester, and acetic acid carboxylic acid. All these three classes of compounds cannot be taken in Clemenson's reduction. So option B it is. Right, you write there Clemenson's reduction. So that implies aldehydes or ketones. No other class of compounds will undergo by Clemenson's reduction. So 56th one. The IUPAC name of the compound. So as you can see there, 2 phenyl groups are there and it's a ketone. So diphenyl methanone, 1 carbon atom if it is, then meth is the word root, then ONE is a ketonic functional group suffix. So you have diphenyl ketone is a common name, not the IUPAC. Benzophenone is also common name, but diphenyl methanone is IUPAC name, option C. 57th one. For a spontaneous reaction, the value of delta G must be, for all spontaneous reaction, delta G is supposed to be negative. So option B. 58th one. Which of the following on heating with the chloroform and alcoholic potash will give offensive smelling compound? So obnoxious smell, offensive smell, or intolerable smell, or foul smell. These are the 4 different words used for same characteristic. That is for which test? Carbylamine reaction. So all primary amines will answer. Okay, all primary amines undergo what? Carbylamine test, carbylamine reaction or test. So therefore primary amine among this only one, that is option A. Next, 59th one, primary, second and tertiary amines can be distinguished by using nitrous acid, then benzene sulfonyl chloride, that is known as Heinsberg reagent, HCl. All the amines will dissolve in HCl, so therefore you cannot distinguish with HCl. So right options are option A and B, so therefore option D to be selected there. Last one, 60th. For the reaction N2 plus O2 giving 2NO, the value of Kc is given. What is the equilibrium constant Kp? Kc, if it is given Kc, how they are connected? We know that Kp is equal to Kc into RT to the power delta N. Now what is delta N? This implies delta N equal to Np, or we write, okay, or also, that is better, okay. Also, how to find out delta N? Number of moles of gaseous product minus gaseous reactant. So right side 2, left hand side also 2, it is, so 0. When delta N equal to 0, Kp equal to Kc. So answer is same, that is 0.1. I mean, how much it is? Value of Kc at 800 degrees is 0.01 it's supposed to be. Okay. When the equilibrium concentration of both the reactants 0.5, what is the value of Kp at the same temperature? So it is nothing but option delta N equal to given, so you have to select the right choice there. Value of Kc at 800 is 0.1 they have given, so that itself is when the equilibrium concentration of both the reactants is 0.5. So you reduce the equilibrium concentration, so we know what happens for the equilibrium constant is depending on the temperature, and anyway here delta N, so you can select the right option as option D, right, because Kp equal to Kc in this case. So with this we have completed the first model paper. Thank you for watching. Okay, we will meet in the next paper, model paper 2. Thank you.